All right, good morning. Today we should really talk about lecture number 7, week 7. I haven't seen any question on the Google Doc. I think either maybe things have been clear to you so far, or maybe you're still catching up with the lecture. If so, please do that as soon as you can. And I think I still got my office hour this afternoon, and also next week you can still ask me questions. But I think the lecture maybe in general is rather clear, self-contained, so maybe that's why you're okay. Let me make some brief announcement here, just about for the course. As I announced yesterday, so for your lecture number 8, we don't actually have that this week. So what's going to happen is you can focus on your written test number 3, and then I will resume the lecture for week number 9 next week, right? It'll be week number 9. And we got 4 more lectures to be covered for the semester. I definitely want to finish as much as I can for the bridge controller, just one more lecture. I will see what I can do within the normal time. And then we're going to talk about one more case study for using formal specification, refinement proof, and etc., which will be the file transfer protocol example. That's what I plan to do. So at least we got 2 case studies thoroughly studied for the course before the exam. So that'll be the plan. And for your written test number 3, it will be happening next Tuesday, right? The normal time. So if you go to the test guide, it specifies exactly what you can expect. So there should be no surprise. The experience should be just the same as the previous 2 tests. Just look at the coverage and look at the example questions on the e-class I just made available yesterday. So try them out, but just make sure your priorities should still be studying for the cover material in the slides and also in the notes. That's for sure, right? Do you guys have any questions related to the course? Anything before I move on to the Google Doc questions? I do have 2 from there. Anyone? Feel free on the chat, or you can just open your mic to speak up. Either way. All right, everybody's okay, I presume, but you can still interrupt me when you need to. All right, so I only saw 2 questions on the Google Doc. Actually, they're from the previous week. I think they were just added, maybe just later yesterday. All right, so the first one. This is really about this particular lecture when I talk about abstract versus concrete state transition, right? You can definitely read the question posed by your fellow students. Let me just get to the point directly, okay? If you kind of remember this kind of a correspondence I show to say, if you try to go from the concrete state using ML out as a state transition, you got this pair of pre and post states. Correspondingly, you also got ML out, the abstract version over here. And I said, as an exercise, you should really try to see whether or not you can do MLN. All right? So your fellow student correctly pointed out, you cannot do that right away. Because right after this ML out, you actually got over here, C is actually equal to 0, which will disable the guard for MLN. So you cannot do that just yet. So that's kind of the response I was expecting from you. So what? So does that mean MLN can never be enabled? No, because at that point in the lecture, we didn't really speak about the 2 new events, ILN and IL out. That's what you would need, right? So the complete story should be, I also wrote my response in the Google Doc. Okay, so what you should really notice is to really complete this exercise over here. So number 1, it is disabled for MLN at this point because C is equal to 0. All right. However, number 2, try adding some transitions by the 2 new events, which we spoke about slightly later in that lecture. So ILN and IL out. In that case, it will actually enable the occurrence of MLN, right? So that will be the kind of the guide I would like to give to you to complete this exercise, just to see how we can do the corresponding ILN, IL out, which will correspond to skip events, right, in the abstract level. And then after these 2, you will be able to do MLN. Right? Any follow-up to this? All right. Any follow-up to this this question here? Everybody's okay? All right, let's move on to the next one. And for this one here, it's mainly just about if there is an alternative way to do the proof, right? So we talk about guard strengthening, you can definitely refer to that particular part of the lecture, right? When we prove the refinements. And over here, let's say this is what we have, the sequence over here. That's part of the halfway through the proof. What we did was, in the lecture, is to apply the EQLR, meaning that we're going to replace every occurrence of A plus B just by N. In that case, we got N less than D and N less than D. So that's why we could use the hypothesis axiom inference rule. Your fellow student was wondering, would it be okay to say from this point over here, we actually use another one? Let's try. All right. So they were asking something like this. Let's say I'll put this one over here, okay, to be here. Okay, I'll write it a little bit bigger. So we got A plus B equals N. And also A plus B less than D, turnstile, and less than D. All right. So this is the sequence we have, right? Alternatively, can we actually do, let's say, EQ rather than LR with the RL? If you decide to do that, what's going to happen is you're going to replace every occurrence of the right-hand side by the left-hand side. The left-hand side is A plus B over here, right? So if you do that, let's say after that, what you're going to have is something like this. So you're going to replace every occurrence of N over here just by A plus B. So this part over here remains the same, right? That one's not really replaced. So A plus B less than D, turnstile, and also A plus B less than D. And don't forget, this equality over here should still be there, unless you say you also apply monotonicity. But now we can say that if you want. So let's say followed by monotonicity, in which case we're going to drop this hypothesis. And once we get to this point, you can see we also got matching hypothesis and the rule. So that's why we can also say hypothesis rule. So this alternative proof also works. In the exam, for example, if you are asked to prove some sequence, of course, you can definitely take any valid approach unless you are required to do it in a particular way. Otherwise, in this case, it's okay too. All right, any follow-up to this about this alternative proof? Anyone? Alrighty. Okay, so that's about everything I could see from the Google Doc about half an hour ago. I just checked. Do you guys have any additional questions? Anyone? Let me take a look at the chat. Will there be any focus on the syntax in Lab 1 for test number 3? Maybe check the guide. I don't think you're required to enter any syntax this time, so I don't think so. But you may just want to review Lab number 1 again, right? I mean, somehow Lab 1 just relevant, right? But in terms of entering ASCII syntax for written test number 3, no, I don't think you'll be required to do that. Awesome. Good. You're welcome. Alrighty. Guys, do you have any more questions? Any more? Yeah, if you guys are still catching up with the lectures, please do so. And we got until next Tuesday, right, for you to catch up. But definitely, you may just want to start planning for your exam already. I haven't seen the exam schedule out, but I presume you. I did actually tell the register office if they can try to give us some gap after the last day for the course, so we can actually let you have some gap to really catch up with the course, and also we can hold some review session for the exam. I'm not sure if they will take my consideration into account, but we'll see. Once I know about the exam schedule, I'll share with you, and then we can talk about how we should plan. But the exam is going to be in person, so it will be some paper exam. So we'll talk about it later once the date is released. Okay. All right, I should really open the floor. And if you guys got any questions, please feel free. It's really your time. If you guys are okay for now, that's fine. I can let you go. But let's wait a little bit longer to see if you got any more questions. I think the example question I gave to you yesterday, I think some of them, of course, rather straightforward, just checking the concept. I would say try to read more into it. For example, if I gave you some example, even though that's simple, but if that's about divergence, or maybe there's something about invariant preservation, so you should really take that as a hint that maybe that particular topic will be covered in the actual test, so you can study further, right? So, and also, I think one of the question was really about given some proof tree. I simply blank out the inference rule that might happen in between the two sequence. There might be some valid justification. There might be not. So that's something also similar to what you did in written test number 2. But that one's a little bit more challenging because you have to see the entire proof tree. So I would say example question they can definitely give you some idea. But still, your priority should be study everything that's really covered. I cannot emphasize that further. All right. Yeah, so Gerard was really mainly talking about the other 8 proof obligation that's really given as exercise. I don't really have the answer myself at the moment, but if you want to check maybe 1 or 2 of them, you can feel free to bring your answer to me during the office hour, and we can walk over some of them. Yeah, I believe the remaining one should be rather straightforward, right? All right, good. But as I said, if you're really asked to really prove something, let's say from scratch, in that case, either myself or the TA, when we grade them, will definitely make sure we actually try to justify, whether your inference rule use is really valid. It may not be the same as what we actually put on the standard answer. That's okay. Just like a previous math course, sometimes it might just be multiple ways to prove things. All right. Alrighty. So guys, we don't have that many participants today, but I did really plan to really do some very little polling on the Zoom. We did actually talk about, like a previous survey. I know that the majority of you guys really prefer to, holding the Q&A over Zoom. But I think some of you also expressed the preference about maybe if that can be held in person, that'll be also beneficial for your learning. How about I run the poll anyway? So for those of you who are here, I think you're more like a regular participants, in the Q&A. Why don't I launch the poll right now? You should see something like that, right? Just tell me. I believe that's anonymous, so don't worry about committing to the option you choose. If I'm going to hold the Q&A, let's say on campus, in the classroom that's designated to the course, in that case, would you prefer to attending it on campus, or you would still prefer Zoom? Let me know. Okay. Give me some idea, because if you all of you still prefer Zoom, then we can save the commute, right? We can still do it over Zoom. That's okay. For that one, I'm quite flexible. Okay. All right. All of you participated, and the poll. Share the results. Well, it seems like all of you still prefer Zoom. That's absolutely fine, right? So why don't we still keep it in the to the Zoom then? That's fine. Yeah, I guess the only chance we're going to see each other will be during the exam, I think. I can ask you guys again, maybe during the exam period, if we're going to run any review session for the exam, I can ask you guys again if you prefer to listening to the Q&A in person on campus. We can consider. But for now, at least I know for the regular participants. Already. Okay. All right, guys. Final call about if you any questions related to what's going to be covered in written test number 3.
I have a question.
Yes, go ahead, please.
One of the inference rules I still find kind of confusing, and I was wondering if you
Yeah, sure. Which one?
It's I think it's the or R one, like the first newest one
Okay.
that
Or
you like.
R1. Yeah, got it. Give me a moment. Let me get prepared. You can also just confirm if this is the one you're talking about. Give me one moment. Let me get it prepared. Bear with me. Let me try to find it out. Okay, possibly over here. Not yet. Okay. Sorry, did you mean this one here, ORR1?
No, I mean it's the or. I think I think it's just or R, and that's it.
Or R? Or okay, ORR, 对不对? Yeah, yeah. Is that right?
Yeah, I believe so. It's like on like the third inference rule page.
Oh, the third. Okay, if you say the third, that helps. This one here?
That's the one. Yes.
Okay, sure. Let's talk about it. No problem. Let me put it on the Q&A over here. Okay, good. Okay. Let me talk about it in general. Maybe if it doesn't quite answer your question, you can let me know. I can try to explain from a different angle. Again, so the general picture about interpreting an inference rule is to think about, in order to prove the sequence and the consequence, it would be sufficient to prove the sequence in the upper part over here, right? That's how we interpret the sequence. So now we are saying the following. If the sequence you want to prove has the goal being a disjunction, right? You can see this is so-called, we call a disjunctive goal, because the goal is a disjunction. So this is a disjunctive goal over here. If you actually want to prove a disjunctive goal, it would be sufficient to prove it if you can choose to prove any one of them. For example, you may choose to prove just Q. In that case, you can move the P itself to be a hypothesis. However, in order to move a goal P as the hypothesis, you must negate it to be not P. Do you follow so far?
Yeah.
Okay, so thinking this way, right? So let's now try to think about the formal meaning for the sequence. If I say I got hypothesis H, I want to say H implies P or Q. And remember the little proof I did in the lecture. So this actually turns out to be equivalent to, I have the same hypothesis, and then I can also try to switch P from the goal into hypothesis, and then not P. This implies the Q, right? You can see we're basically still trying to prove Q over here, and Q is part of the disjunction. If we are able to prove Q, that should be enough to prove that the disjunction originally was actually true, because anything is true for the disjunction, the whole disjunction will be true. And then the advantage is we can move the P over here as an extra hypothesis. You can think about this as the extra hypothesis we can use, which is the negation of one of the goals. Does this kind of help, or you actually are expecting something more?
This does help, but I was wondering if you could show like maybe like a more like maybe like
Example.
an example, because like, and I think like in like in the last the last two slides, like there was like that big proof problem, and in that problem we use the OR, and I remember that was like part of where like.
Oh, that's the part you're confused. All right, sure. Let's go for that part then. OR R. Let me see where it is. Oh, there's ORL. So we need to find ORR. There we go. I think that's the one. Okay.
Yeah, that's the one.
Yeah, I got it. I got it. Good. Why don't I just talk about this part? Because that's the part you're confused, right? Okay, very good.
That helps.
Okay, good. Let's talk about this specifically. No problem. Okay. Let me paste it over here and let's talk about it specifically. Very good. Okay. Okay, good. Right, so there are actually several things you want to think about over here. Okay, let me just take a look. Got it. Okay. Let me try to help you a little bit further because you can see when we go from here to here, we actually apply two inference rule. One will be ORR, which we just spoke about. The other one is about some simple arithmetic. So that's kind of the two steps. So let me now try to do it from two, okay, from two, separate steps. Let's try to do that. Okay. So let me just crop it. Let's go from here. Okay, let's start with the original one. Okay. And the first one we're going to do will be ORR. And if we apply it, this will be, you can see this is part of the disjunctive go, right? It's like a P or Q. Apparently here we got several disjunction. We can just choose one of them to move them to the hypothesis by taking its negation. So if we do this, it's going to be something like this. It's going to be D larger than 0, A natural number, and B natural number just the same as before. And then not the case, A larger than 0. Turnstile, and then since we move it, so we only got 3 left, right? Let me write it down. A plus B less than D, and 0 equals 0. Or 0 larger than 0, or B larger than 0, and A equals 0. All right? So the main thing we did, oh, actually, let me box better. Let me just try one more time. There we go. All right. So for this part over here, I want you to look at here. We identify this hypothesis over here, and then we put its negation. And we identify this goal, and then move that as a hypothesis. Are you okay so far about this?
Yes. Oh, and I see. So basically, and now basically, like,
Yeah.
that one's basically saying
Exactly.
it's not greater than 0.
Yeah.
And since it's a natural number, that means it has
Exactly.
to be equal to 0.
Exactly right. Yeah. That's kind of the hand waving idea in the lecture. Maybe that's the part you missed. You're right. So
Yeah.
now we can look at So now we can look at these two, and these two together, as you said, combined together, you're gonna get A should be exactly equal to 0, right? And then the rest will be just the same. Yeah. All right, and then of course we can still have A is a member of. Yeah, you can see the point, and then of course you can apply monotonicity to drop these two if you wish, but you kind of get an idea, right? So I can just stop here.
Yeah, I get it. All right, perfect. Thank you very much.
No problem. Okay, good. And you guys can imagine, for example, right? Let's say in the actual test, kind of in a similar format as what you were given in the example question. For example, if I gave you, let's say, this sequence over here, and also this sequence over here, and then I blank out step number 1 and step number 2. So, and then you will be required to tell me which 2 steps should be used in sequence to really justify this step. So I'm glad you asked me this question. I think this will be a nice one as well, right? Just remember. All right. Right. One question from the chat. Let me take a look. Will the formats of test number 3 be similar to test number 2? Yes, that's correct. Mostly multiple choice and multiple selection. Absolutely. I think format wise, it would be definitely much more similar to test number 2. Unlike test number 1, I think for test number 1, it's not that majority, but for test number 1, you were asked to really enter some ASCII character syntax for the math, but it's not the case for the written test number 3. Okay. I'm a little bit confused about how we would express full proof. I think it's really the limitation for how to assess this kind of stuff on the E-class. But I think what I could do, at least, is to maybe give you some partially completed proof tree and then let you fill in a step. And then to really see if you can really do some proof from scratch. Maybe I'll leave that to the in-person exam, in which case you got some nice piece of paper with lots of room. In that case, you can sketch out your answer. I think that's what we might do. But I think at least for the written test, we can definitely give you a question like this. In terms of the number of questions, I don't want to commit for now. But I would say you can expect the level of similarity. Oh, sorry. You can expect the level of intensity or difficulty of written test number 3 to be somewhere between the first and the second test. Somewhere between. I.e., it's going to be harder than the written test number 2, but it will be easier still than written test number 1. Somewhere between. That's what I meant. But that's also something I mentioned in the test guide. I'm just repeating it, right? Also, it's kind of natural. It will be a little bit more difficult than written test number 2 because the material that we actually newly cover after written test 2 about, for example, deadlock freedom, invariant preservation, and also divergence, and also the more inference rule for the proof. I think these kind of stuff were newly covered, so that's why the test can be naturally just harder than the second one. But I'll still try to make sure it's still below the level of the intensity for written test number 1, right? So Jara, does it make sense to you? I hope that's kind of what you expect to hear, right, about the answer. Just make sure.
Oh yeah, and speaking about like test 3 and stuff, I actually have a question about the what's it called, the practice test 3 that you released yesterday.
Right.
It has to do with question 4 of that test.
Let's take a look. Give me a moment.
Yeah, sure thing.
Sure. And example question for written test number 3. Okay. And then let me preview. 1, 3. You said this one here?
Question 4.
Question 4. Okay. This one here?
That's the one about, yes, that's the one about that.
Okay.
Yeah,
sure.
yeah.
Mm-hmm.
Okay. So from like when I went back into like the lectures and looked at like the deadlock stuff, the when it comes to like solving or like to finding like the goal of the sequence
Mm-hmm.
in the lecture, all it was is that you just grabbed like the basically the guards of like the events and then just put them at the end, and like I think you like ordered them or and them. I think it was and, but
or
so I
and. You should take the disjunction of all the guards, not the conjunction. Disjunction.
Oh yeah, right, yeah. So I assume that the goal in this one would be to get you basically just grab the n is less than d, and then n is equal to 0. Or sorry, is that equal? I can't really see it on my screen. Yeah, those two things.
Yeah, exactly. Mm-hmm.
Yeah, but when I answered them, one of them was the case, but the other one wasn't.
So the answer should be these two, I believe. N less than d, and also n larger than d. Oh, sorry, n less than d, and also n larger than 0. I thought these two should be the answer. No?
Yeah, but I think one of them was, but the other one wasn't. That's the thing. And I think that kind of like confused me, and I thought maybe that might be a mistake.
Let me see. Unless I make the wrong answer, let me take a look. We can take a look right away. Yeah.
Yeah, like I'm pretty sure.
Mm-hmm. You might be right, but let me take a look.
Yeah, just double check just in case.
Yeah, absolutely. I'm glad you pointed out. Okay. Sequence go. Okay, let me just go there. Okay, very good. So the correct answer should be N. Aha! You're right. Actually, thank you. Okay. Yeah, thank you. You're absolutely right. I'm glad you asked. Yes. N less than D for sure. And also should be another one. N less than D. And also, can you remind me what the other one should be? N larger than 0, right?
I think so, yeah.
Thank you. So I think a 50 and 50. Yeah, I'll be much more careful. Don't worry. When I actually give you the answer for the actual test, don't worry. I kind of did this slightly.
That kind of confused me. I was like, wait a second, isn't this supposed to?
Yeah, exactly. Yeah. Now, guys, if you really see some example question which doesn't make sense to you, please ask. I could be wrong, but I'm slightly sloppier, in getting the answer, to assign a percentage when I did it, without double checking. But normally I do double check for the actual test. Yeah, Jira should be okay now, but we can double check for sure. Let's say we go back to here. And then if I try this guy here, and also n less than d, and let's say we submit. Yeah, I think we are fine. Yeah, it's fixed. Yeah, good. Alrighty. Okay, let me go back here. Yeah, so there, if as long as there's enough time to think over our answer, then that's great. Yeah, I will definitely make that into consideration. It's a fair request. I'll try. Yeah. All right, guys. Any more questions? Any more? All right. So, yep, I would say good luck to your study for the written test number 3. And looking ahead, after your written test number 3, we got one more written test. And for those of you who actually chose to take the programming test, I will send you the instruction very soon. We still got some time. But we got one more written test, number 4, around the final week of the term. And then we got the exam. I'll definitely give you some guide. And then as to how you should really get prepared for the exam. All right. Alrighty, guys, thank you so much for coming. And then I would say good luck. I still got office hour today, 2 p.m. or Monday, 2 p.m. Speak to me if you got confusion, doubts. Otherwise, I'll see you next week. You guys take care. Have a good day. Bye-bye.